we will talk about the introduction, that is basically the difference between the additive manufacturing and subtractive manufacturing. Additive, that you are just depositing the material layer by layer, while subtractive, you are just removing the material. So that is the basic difference between these two. Once we will talk about the industrial applications of AM, once you will see the additive manufacturing are mostly benefited by the biomedical and for the automotive sectors as well. So if you will see that almost 56% of the parts which are manufactured by additive manufacturing, either they are prototype, they are fully functional components, or they are end-use products as well. So at the start of the additive manufacturing, it was considered as it is just only for the prototype. The prototype means that you can just see the design or the concept, that what is the visualization of your product is. But as the time progresses, this prototype has been shifted, this additive manufacturing has been shifted from prototype to your production line as well. So that is the basic, you can say, the main theme or the main idea of this talk as well. If we talk about the advantages, like why we need the prototypes, I think if you will see the successful models from the concept to the product, the prototype is the backbone of that one as well. Because every time the prototypes will be considered that it should be cheap, and we can make the iterative approaches to make a successful design. But as I said that before, once AM has been came into being, that is only considered for prototype. So moving forward, there are 7 different categories of additive manufacturing. But if we will talk about, for the Pakistan point of view, most of the people just think that FDM and SLM, that is the only 2 additive manufacturing techniques, but it is not. We have 5 other methods as well. So according to your own application design or the usability of the product, you have to select the product, or you have to select the process for which you are going to print your part. So material jetting, wet polymerization, SLM, material extrusion. I will just want to quote it here, that selective laser melting, that is called the metal printing as well, that is the functional parts were manufactured by this technique. Design for additive manufacturing, once we talk about that one, you don't need any toolings, any jigs, any fixtures in that one. You have the design capability, whatever you have in your mind, you can just design and you can print. Once we talk about the generative designing, that with the help of simulations, you will get the data, and then you will use that data as your iteration for the finished product. So this approach will give you 2 types of structures. Either they will be functional graded, in which you can call it a topology optimized, in which the material distribution can be controlled according to your stress-driven map. Or your part can be stress-driven structure, that where you have the maximum stresses, you will have maximum material over there. And where you don't have any stress, you can have the porosity or voids over there as well. Design for additive manufacturing, if you talk about that one, there are design features. As I said, there is unlimited design freedom. Whatever you have, you can just only design in the CAD model, then you just make it to the slicer and you can just print those one. Process capabilities, tools. Once we talk about the tools here, basically the CAD modeling, the software that is considered as the tools here. You don't need any jigs or any fixture or special environment for that one as well. Further, if you will see that I will try to quote some examples by which the idea will be, you will just come to know that this additive manufacturing is not only for the prototypes anymore. There are some success stories which has been considered here or which has been flashed here. So as I said, unlimited design freedom. If you have the part like this one, I don't think so you will be able by manufacturing by traditional manufacturing. So you always have to go for additive manufacturing. So unlimited design freedom. Once I have quoted here some printed geometries which are different industrial applications, and they are made by additive manufacturing from different processes and from different materials as well. The biggest you can say the drawback which is associated with additive manufacturing and traditional manufacturing is the cost. So here I have described a graph which is showing that what is the relation between the cost of traditional manufacturing and your additive manufacturing. If you will see the additive manufacturing, the cost is constant. But once you will talk about the traditional manufacturing, if your part is the complex one, the cost will be higher as well. Until and unless you will going for the batch productions or high volume, then your cost will come down. But in other graph, you can see that there will be the one point will come where traditional manufacturing cannot make your part due to the complexity, and you have to go for the additive manufacturing. Nowadays, the people are just trying to do that one, that R&D they will be doing with additive manufacturing, and later once they have to move for the high volume, they are going for the molds and fixtures. They are just going to design with the help of additive manufacturing. So hybrid additive manufacturing is the latest concept as well, in which traditional and additive manufacturing are merged together. These are some of the industrial applications. There is one Wooler's report which is around the globe. They are just getting the success stories from all over the world, and they just make the comparison about additively manufactured part and if those parts are going to manufactured by traditional manufacturing. So if you will see here that optimized part, once it is optimized by using design for additive manufacturing, the cost is also reduced and the manufacturing time is also considerably reduced as well. Moving forward, and lightweighting is achieved. Lightweighting, that is the unique, you can say, advantage of additive manufacturing as well. Before that one, they are done by the topology optimization. But nowadays, the lattice-based manufacturing, that is considered as the advanced manufacturing technique as well. That what you are doing, you are just using different lattices, and according to these lattices, you are just finding the best stress map, and you will get the optimized structure as well. These lattices are the, you can say, if you will talk about that, how it will be came out, they are inspired from the nature. Like if you will see the bone structure or the wing of the dragonfly, you can see that there are some structures that is repeated after a certain interval. So that idea has been taken from there, and if you will see that this star shape, I don't think so that traditional manufacturing can be able to manufacture such kind of parts. And we are just making these lightweightings for your implants, even automobile industry and aerospace industries as well. Moving forward, that is the major milestone of additive manufacturing. Whenever you will talk about additive manufacturing is used as a production method, this approach or this example will be quoted. That is GE nozzle that is used for the aircrafts, and by using additive manufacturing, this part by the traditional manufacturing, 20 different parts or the 20 different sub-assemblies will come into being and they will generate one part. But with the help of additive manufacturing, you can just make it in one part. So the part have been reduced from 20 to 1. And similarly, if you see the weight reduction is 25% and inventory reduction is also 95% has been reduced. So that is the major milestone of additive manufacturing, GE nozzles, that is will be considered the additive manufacturing's milestone as well. Moving forward again, roller screws, again the 7 different parts and 7 different sub-assemblies, but now they can be only manufactured in one assembly, and that part is also reduced your manufacturing time. Similarly, your weight has been reduced as well. Sorry to say, I'm just moving forward because we are already lacking with time as well. So non-circular holes, that is again like in your different LNG tankers, they are used. Again, if you see the design of that one, these holes are not circular. So that cannot be made, or with the traditional manufacturing, that is a hell of task. So what they have done, they just try to alternate the different designs at their prototyping phase, and then they come up to one design in which their ratio has been also increased as well. The new fuel atomizer, your aspect ratio has been, your burner ratio has been reduced from 15:1 to improve to 25:1. That is again has been manufactured with the selective laser melting and only in one single part. Similarly, medical arm braces, there are so many examples which will just prove that one, that additive manufacturing is not only for prototyping anymore. There are fine features, they are also manufactured by SLA, by binder jetting, material jetting, and selective laser melting as well. What are the business benefits we are achieving? They are tooling free manufacturing. As I said, there is no jigs and fixtures are involved. Your tools are only CAD model and one printer. Supply chain re-engineering, then mass customization, and cost and speed are also effectively reduced as well by using this technique. There is one example of part optimization. Like if you have two different parts, you just combine them together, and then you just with the traditional manufacturing, you can see you are using the same tools. But if you see at the last two ones where you have introduced the lattices, due to these lattices, you are reducing the weight, and also you are getting all the benefits of AM and getting the stress driven or functionally optimized structures as well. That is the cost, that how the cost has been reduced. So you can see the previous cost was almost $350, but now it is reduced to $249 as well. Okay, moving forward. Now, what are the challenges in Pakistan, that why additive manufacturing is not been the first choice for the manufacturers? First of all is the import dependency, and those who are involved in this business are also involved in this research. They know about that one, that how difficult it is to import a one 3D printer in Pakistan. Lack of awareness, because Pakistan is lacking from this technology. So that's why 3D printing is considered to be a very advanced manufacturing technology, which is not anymore. Yes, for the last 5 or 10 years back, it was considered a very innovative technique, but now there is 4D printing is already in the market. So just because of the lack of awareness, limited R&D infrastructures, resistance to change, that the people of Pakistan or the students of Pakistan is just lacking behind that one. Because we are from academic section, so we see every day such kind of examples as well. That if they design, they simulate, they don't have the infrastructures for the printing. So that's why they have to see some certain outsourcing, but they will quote that much cost that it is impossible for the student to just go for the design and the print for those ones. Then OTS, there are contributions for that one, that they are just highlighting or they are engaging the students for that one as well, and they are just have those facilities. Of course, they have their own businesses as well, and according to that one, they just provide the printing facilities as well. Last but not the least, that is the concluding remarks from, because I am from the academia side, so I always urged for that one that there should be additive manufacturing center in which all the industries and all the Pakistani universities, they will be collaborating with each other. Anybody can access for those ones, and there should be all those categories will be available over there for the students' use, and the people from the industry, they will get their solutions from that research center. So that is due to that one, you will see that the programs will be developed as well, and there will be awareness among the students for this technology as well. And the last, that the academia and the industry linkages will be strengthened by this kind of collaboration as well. So because we at NUST, we are working on such kind of structures as well, but the printing and the experimental testing is the biggest hurdle for those ones.